Question 2. A time-of-flight mass spectrometry is an important analytical technique. A mixture of three compounds are analyzed using a time-of-flight mass spectrometer. The mixture is ionized using electrical ionization. Three compounds are noted after molecular formulas. These. Describe how the molecules ionized using electrospray ionization. Electrospray ionization. So the sample is going to be dissolved. Sample is dissolved in a volatile solvent, injected through nozzle at high voltage, positively charged, and each molecule gains a proton, H+. So, electrospray ionization, just how well do you know electrospray ionization, electric impact ionization, acceleration, what is the other thing, ionization, detection, all of those, you do need to know them in detail. So a sample is dissolved in a volatile solvent, injected through nozzle at high voltage / positive charge, and each molecule will gain a proton. Sample dissolved in a volatile solvent, injected through nozzle at high voltage, positive charge, each molecule gains a proton. And 2.2, give the formula of the ion that reaches the detector first in the time-of-flight mass spectrometer. So it's going to be the one with the lowest MR, right? Because that's going to be the fastest. So if we look here, the one with the lowest MR is clearly going to be the first one, C3H5O2N. However, because we're ionizing it using electrospray ionization, we know each molecule gains a proton, H+. Remember, electrospray ionization. So it's going to be C3H5O2 and H+. C3H5O2 and H+. That one's slightly tricky. If you got 2.1 correct, each molecule gets a proton, H+, so therefore the one with the lowest MR, just add a proton at the end of it. 2.3. A sample of germanium is analyzed in a time-of-flight mass spectrometry using electron impact ionization. Given the equation group states in multiple process that occurs during the ionization of germanium atom. So it's going to be germanium in gas, germanium in plus gas, plus E minus. So very similar to first ionization energy, or is it the same? I'm not sure. I think it is. But that's the electron impact ionization. You've got the positive charge, the gas, and the electron, and then you've got the simple atom, in this case, your state. And then 2.4. Loads of information which I'm not going to read. And it says using information calculate mass in grams of 1 mole of germanium atoms. Okay. So we know germanium ion reaches the detector in this much time. I'm just going to highlight the key details. So what I'll actually do is I'll write down everything we know. The time equals 4.654 times by 10 to the power minus 6 seconds. KE equals 2.438 times by 10 to the power minus 15 joules. So find the correct units, and then the distance. Okay, the length of the flat tube, 96 centimeters. We want that in meters. So it's going to be 96 divided by 100, 0.96 meters. Meters. I could just wrote M, but I prefer meters. So now what this means is that I no longer have to, read through the thingy again. I've already got the information plotted for me. And we also know Avogadro's constant is that. Okay. We want to calculate mass in grams of 1 mole of these germanium ions. So how do we do this? Well, what we can do first is, you know, now we can find out the mass, because we know if we just rearrange it, mass is 10 by 2 ke over mv squared. 2 ke over v squared, which is what we now found out the velocity. So yeah, I can do that. 2 times by kinetic energy, 2.438 times by 10 to the power minus 15, divided by 26, 206,274 squared. And then that's the mass of the ions, but we want it in 1 mole, so we need to times by Avogadro's constant. And this is in kg. And then it'll give me 69 grams. And then for the mass number is 69. Difficult part is understanding that the mass we calculated now is in kg, and then we need times by 1000 again, and we also need times by Avogadro's constant to get the mass of the ions, the 1 mole of ions. And apart from that, it's pretty calm. And that's the end of question 2.